In this video, we're going to look at limit laws, just basic limit laws. So there are 5 basic limit laws, as listed right here. All of them are true if the limit as x approaches a constant c of f of x and the limit as x approaches c of g of x exist and are not equal to positive or negative infinity. So first is the sum law. If the limit as x approaches c of a sum of 2 functions, if that's what you have, you can split that into a sum or a difference of 2 limits of those functions. So the limit as x approaches c of f of x plus or minus g of x can be split into 2 limits, the limit as x approaches c of f plus or minus the limit as x approaches c of g of x. Second is the constant multiple law. So for any number k, where k is a constant, if you have the limit as x approaches c of a constant k times f of x, you can pull that constant out to the front of the limit and write it as k times the limit as x approaches c of f of x. Then we have the product law. The limit as x approaches c of f of x times g of x can be split into a product of 2 limits, the limit as x approaches c of f of x times the limit as x approaches c of g of x, which is similar to the quotient law. As long as the limit as x approaches c of g of x exists, meaning and not equal to 0. I should have put that there. As long as that exists and is not equal to 0, then the limit as x approaches c of a fraction can be split into the fraction of the limit. So the limit of the numerator divided by the limit of the denominator. And lastly, there is a law about powers and roots. If n is a positive integer, then the limit as x approaches c of a function to the nth power, if that's what you have, you can pull the limit inside of the exponent. So that's equal to the nth power of the limit as x approaches c of f of x, which is really the same as pulling a limit inside of a radical. So if you have the limit as x approaches c of the nth root of f of x, you can pull that limit under the radicand to give you the nth root of the limit as x approaches c of f of x. Okay, most of these seem a little maybe odd, but they're much more clear when worked with an example. So what we're going to do is use limit laws to evaluate the limit as x approaches 2 of x squared minus 2x plus 8. And then we'll use also the limit laws to evaluate those 2 functions. Okay, using limit laws to evaluate this. Well, you could do it graphically. You could look at the graph of the square root of x squared minus 2x plus 8, and when x approaches 2, you could see what the y values are approaching from both the left and right. Or you could make a table of values and find it numerically. But essentially, because this is, I believe, continuous at 2, you're just plugging in the y value of 2. Okay, which is not exactly what we're going to do here. We're going to use the limit laws one by one to evaluate this limit. Okay, first I'm just going to copy the limit. So the limit as x approaches 2 of the square root of x squared minus 2x plus 8. Now, the first limit law that we're going to have to apply is this one right here. We can bring the limit underneath the radical. So we can write this as the square root of the limit as x approaches 2 of everything under the radical, x squared minus 2x plus 8. Okay, and that is by rule number 5, the one right here, powers and roots. I'm just going to put by number 5 is what allows me to do that, to pull the limit under the radical. You do not have to quote the numbers or the rules at all. You just have to be able to show your work step by step. Okay, next I will need to evaluate the limit of this polynomial. Okay, now you probably know that polynomials are continuous and smooth. I mean, there's no problem. You can just really plug in 2 to see what the y value is going to be. But I want to find this limit by using the limit laws. So the next thing I'm going to do is have to split this limit of the sum of these 3 terms into a sum of 3 limits using the sum law. Okay, so we're going to write this as the square root of, this will be a little bit long this step, the limit as x approaches 2 of x squared minus the limit as x approaches 2 of 2x plus the limit as x approaches 2 of 8. Okay, let's see, let's add parentheses there, and let's write that is by the rule number 1. Now we need to find these 3 limits, okay? So this first one could be found by pulling the limit inside the exponent, which is rule number 5. So that's equivalent to the limit as x approaches 2 of x, all squared. Here we could pull the 2 out and write it as minus 2 times the limit as x approaches 2 of x. And then there's really nothing to simplify here. So let's just go ahead and find it. Okay, over here in the scratch work on the side, let's put it over here. The limit as x approaches 2 of the number 8. Okay, here's an xy axis, 1, 2, 3, 4, 5, 6, 7, 8. Here's the line, let's do it in blue. Here's the line, close enough, y equals 8. Okay, if x is approaching 2, it ought to be pretty obvious that whether you approach 2 from the right or approach 2 from the left, your y values are always 8. Okay, so the limit is going to equal to 8. Okay, so this limit as x approaches 2 of 8 is equal to simply 8. All right, then to take the next step down here, we need to find the limit as x approaches 2 of x. Okay, so for that limit, the limit as x approaches 2 of x. Let's draw another xy axis. The line y equals x, that's the function, y equals x looks like that. So when x approaches 2, you can see pretty clearly that from both the right and the left, those y values are going to also approach 2. So that limit is equal to the value of 2. So we have the square root of 2 squared minus 2 times 2 plus 8, which now is just arithmetic. So 4 minus 4 plus 8, we have square root of 8, or 2 root 2 would be that exact answer. Okay, so that's how you can find a limit using limit laws. You do not have to be able to write all this out. I just want you to understand, what the limit laws are saying. These are technically the foundation of like derivatives. Okay, so I will refer back to these later in this course when we get to certain derivative rules. I'll say, remember that limit law, and then kind of use that as an explanation for why we can do certain things with derivatives or integrals even in the future, but mainly derivatives. I'll refer back to this. Okay, and to see if you really understand, here's just a couple of challenge questions. So what you ought to do is pause the video and attempt these on your own first. Okay, so we're given 2 limits. The limit as x approaches negative 4 of f of x equals negative 3, and that the limit as x approaches negative 4 of g of x equals 2. We want to find these 2 limits. First, the limit as x approaches 4 of f of x squared. Okay, so using limit laws, we could pull the limit inside the square. We could write it as the limit as x approaches negative 4 of the function f of x, which we don't know what f of x is. We can pull that limit into the square, so it's the square of the limit. Now, I don't know what f of x is. I don't have a function for it, but we are given that the limit as x approaches negative 4 of f of x is equal to negative 3. So we can simply plug that in and we get negative 3 squared, or 9. Oops. Okay, and then in the second example down here, we have the limit as x approaches negative 4 of the fraction 2 times f of x minus g of x over x squared. Well, we don't know f or g, so we're going to have to use limit laws. The first one we're going to have to do is to split this into the limit of the numerator divided by the limit of the denominator. So it'll be the limit as x approaches negative 4 of the entire numerator, 2 times f of x minus g of x, all over the limit as x approaches negative 4 of the denominator, x squared. Now, in the numerator, I'm going to apply two laws at once. I'm going to split this into the limit of the difference into a difference of two limits, and I'm going to pull the constant 2 out. So I'm going to pull the 2 out front, have 2 times the limit as x approaches -4 of f of x, minus the limit as x approaches -4 of g of x. It's splitting the limit of the difference into a difference of two limits and pulling out the constant 2. Then in the denominator, we can pull the limit inside the square and write it as the limit as x approaches -4 of x all squared. Now, in the numerator, the limit as x approaches -4 of f of x, that is given right here as -3. So we have 2 times -3 minus the limit as x approaches -4 of g of x is given to equal 2. And then the limit as x approaches -4 of x can be found by looking at this graph right here. Here's 1, 2, 3, 4. That's going to put you 1, 2, 3, 4 down. So you can see pretty clearly that when x approaches -4, the y values are also approaching -4 from both the right and the left there. So in the denominator, that limit is equal to, the limit as x approaches -4 of x is equal to -4. And then we'll square that. So we have -6 minus 2, or -8 over -4 squared is 16, which reduces to -1/2. And that's all for this section.